Very well. So let us continue our lecture. We're going to talk about L'Hopital's rule. Let me go through this one and the other one. So L'Hopital's rule officially say that I keep forgetting about S. So L'Hopital's rule says that suppose you have two functions and you have two differentiable functions. It means that the limit of the direct definition that we define for the derivatives, both of limits exist. Let f of x and g of x be two differentiable functions, and suppose the derivative of g is never 0. Very well. Consider the derivatives on an open interval. Remember that we are really concerned about the boundaries from left, from right. So when we are talking about differentiability, we try to avoid the boundaries over an open interval like a comma b. And suppose the limit of function f as x approaches a number like a is equal to 0, and also the limit of g of x as x approaches a is also 0. Well, we can write down the second case down here. Then the limit of f of x divided by g of x as x approaches a is similar to the limit of the derivative of f over the derivative of g as x approaches a. So note that if at this point you take the limit of the derivatives and it is still, note, if it's still equal to 0 over 0, then we have to continue taking the derivatives from the top, from the bottom. This is equal to the limit of second derivative of f, the second derivative of g as x approaches a. And again, if this is equal to 0 over 0, you can continue taking the derivatives from top, from the bottom, and find the limit eventually. Well, we have another case if it's 0 over 0, or if it's infinity over infinity. Note that we can apply the L'Hopital's rule when the limit of f of x over g of x as x approaches a is equal to positive negative infinity over positive negative infinity as well. It means that the limit of f of x over g of x as x approaches a is equivalent to the limit of f prime of x over g prime of x as x approaches a. And again, note that if still you get infinity over infinity, note, if we still have infinity over infinity plus minus, then we can continue this process. We can take the second derivative of f and second derivative of g. And you can continue this process until you end up with something that is not in the indeterminate form, 0 over 0, infinity over infinity. So we're going to write this down with 3 dots. So a couple of examples for us, see how we can apply L'Hopital's rule. We saw some examples before, and let us take a look at more examples. So our very first example says, hey guys, take the limit of this rational function. What is the limit? I'm not asking to find the derivative. I'm asking to find the limit. Find the limit of ln of x divided by x minus 1 as x goes to 1. Guys, be careful. If you're confusing this with taking the derivative, you might end up applying quotient rule. I'm not asking to take the derivative. Let me write that note here for you. Note. This question is not asking to take the derivative. So we cannot apply the quotient rule. That's an important note for you. Well, question says, hey, take the limit. Remember that very first step in taking the limit, step 1, was substitution. Sometimes we're lucky by substitution, we get a number. So let's plug in 1. We get ln of 1 divided by 1 minus 1. ln of 1 is 0. 0 divided by 0, it is in the form of indeterminate form. So in step 2, we try to get rid of the factor that makes 0 over 0. But here, well, we cannot apply factoring. Here, we do not have the technique of using the conjugate. We cannot do that. What we can do, we can use what we learned so far, L'Hopital's rule. L'Hopital's rule says, well, just take the derivative of numerator, take the derivative of denominator, then start finding the limit. So this is equivalent to the limit of the derivative of ln of x divided by the derivative of x minus 1. After that, we start sending x to 1. So remember that when you're taking the ln of u of x, if you have u of x, the composition of two functions, the derivative is equal to u prime divided by u. So now here you have ln of x. The derivative of x is just 1 divided by x itself. So on the numerator, I have 1 over x. On the denominator, the derivative of x minus 1 is just a linear expression, is 1. And my x goes to 1. So now at this point, I substitute. I already applied L'Hopital's rule. Now the step is substitution. I get 1 divided by 1 over 1, which is equal to 1. Nice and easy. The y value, remember that the limit is the y value. The y value as x approaches 1 is 1. on the vertical axis. This is our y value. I'll give us another example. Let's make it a little bit more interesting. Suppose the question says, well, find this limit.